Okay, so reminder, again, a lot of people did not see or forgot or whatever to do the back. So this warm up, we already talked about this, but just so I can write it down here, we saw that connected by rectangles is a prism, right? So what kind of prism is it? There's a six-sided figure. It's a hexagonal prism. This is just the warm up. I'm going over it for the video here. And then we said surrounded by triangles is a pyramid. If the center is a rectangle, it's a rectangular pyramid. And then we said there's a special case when it's all squares. That's a cube. Everyone's got the warm up. Here's the notes. Okay, for today, we got to talk about cross section. Okay. How many of y'all ever seen a big old block of cheese? Okay. And then, okay. But then, if you want to put that on your sandwich, you're not going to put a big old block of cheese on your sandwich. You're going to do what? Get a little slice of that. Okay. Now, have y'all seen? I'm sure y'all have seen those little individual sandwich slices of cheese, right? You know what I'm talking about? Like you have to peel it, put it on your sandwich. Okay. So today, if I were to tell you the notes in one picture, it's a slice of cheese. Because today, cross sections are basically slicing something like a slice of cheese. So let's do these notes real quick. We're going to make this as quick as we possibly can, okay? Now look, a cross section is the shape made when a solid is cut by a plane. Write this down. Solid cut by a plane. If you take a 3D figure and it's like you're slicing it with a very sharp knife and you make a little slice, that's called a cross section. It's the section that you cross when you slice it. Now, cross sections are usually parallel to the base. Parallel to the base, but they can be any direction, as you can see in this picture. When they are parallel to the base, it matches the base. And this is the most important thing that you need to know. If you cut parallel to the base, it matches the base. Bless you. So look, y'all see this pyramid on number 1? It's a rectangular pyramid. Okay. When it's a rectangular pyramid and you cut parallel to the base, this little slice, I'm going to outline it. This little slice is a what? It matches the base. What shape is it? It's a rectangle. Are y'all hearing me over there? Hey. So again, the bottom is a rectangle. When you slice parallel to the bottom, the base, you get another rectangle. Write that down. Oh, I thought you took my drill. Okay, now, here's the dealio. On number 2, does everyone know number 2 is a cone, right? What is the base of a cone? Y'all can see it right here. The base is a cone. The base of a cone is a circle. So if I cut parallel to that circle, I'm going to get another circle. So go ahead and, if you want to draw that little slice, it's a circle. Go ahead and write circle. We're basically answering the question, what is the slice parallel to the base? It's going to match the base. So number 2 is a circle. Okay? Hey, put the phone away. Number 3, what is the base of this pyramid? 1, 2, 3, 4, 5, 6. It is a hexagon. So when I slice it parallel, you get a little hexagon. So you're basically, if you slice parallel to the base, whatever the base is, you're just making a little slice of that. Pretty easy, right? Now, 4 is slightly more complicated because on number 4, it's sideways, but you can see the slice. So what's the base of this prism that's sideways? triangle. So when I cut parallel to that base, I'm going to make another triangle. You want these, the top part of the notes? Oh, here it is. Bam. Okay, and then number 5. When I take by the way, you know what the name of a ball shape is? Sphere. So it's like fear with an S. Sphere. So if you cut that sphere, what do you get? Think of like the equator. It goes all the way around. It's actually just a whole circle. Okay. So when you cut it, you get a whole circle. Okay. Think of like Easter egg. You pop them open, and what's the edge? It's a circle, right? Or an oval. Anyway, circle. When you cut this, it's half, but then it goes all the way around, right? Circle. So the big thing, when you cut parallel to the base, it matches the base. Okay, so that's 1 through 5. Cool. Now, look at number 6. 6 and 7. I didn't plan it this way. But number 6 and 7 have to do with this picture off to the right here. Now, look at number 6. It says, what is the cross section formed by a plane containing a... Underline it. This is different. It's vertical. Okay. So, everybody, number 6 and number 8, you're going to notice on these notes, say the word vertical. So these are the one situation where you're not going to just look at the base, okay? When number 6 says, what is the vertical cross section, you're going to look vertically. Now, you tell me, what do you see straight up and down? What is this shape right here? It's a rectangle. Or if you cut it like this way, cut, cut, cut. Either way you slice it, no pun intended, you get a rectangle, okay? Straight up and down for a prism. When you cut it vertically, you're going to get a rectangle. Because what do you see up and down? A rectangle, okay? So what's the key word there? Vertical, up and down, okay? But look at number 7, 6, 7. What is the cross section form that's parallel to the base? And what did we just say for those of you who are out and doing other things? Parallel to the base matches the base. So what is the base? 1, 2, 3, 4, 5, 6. The bottom base is a 6-sided figure. So parallel to the base, when you cut it, is going to also give you a 6-sided figure, a hexagon. Even if you cut it like right here in the middle. Check it out. 1, 2, 3, 4, 5, 6. No matter how you slice it. Okay. Parallel to the base matches the base. Vertical matches the vertical. That's how it works. Now here's a weird case. What if it's a cylinder? Number 8 says, what if you cut this cylinder vertically? So let's think about this. If I cut it straight across, straight up and down, straight across, and straight up and down. If I cut a cylinder straight up and down vertically in half, what am I seeing right there? A rectangle is correct. Correctangle. Not even one laugh. Not even one like and subscribe. All right, so rectangle, if it's up and down, vertical. So remember, vertical is up and down. Vertical is up and down. But the next one says, what about if it's parallel to the base? Wait. What is the base of a cylinder? What do I see at the bottom here? It is a circle. Even if I cut it up here, it's a circle, right? Circle. All right, go ahead and flip it over. Now, yes. Now, here's the deal. I'm holding this in my hand. Now, what are these called? For those of you who were here yesterday, what's the flat thing called? It's two-dimensional, but it's called a net. Okay? So here's what we learned yesterday. You can take a flat bunch of shapes like this, fold it from 2D to make it 3D. And now I have a 3D solid, right? And then today we're learning that you can just slice it and then you go back to a 2D shape. And now I'm going to show you that if you rotate it, you can turn it back into a 3D shape. That's crazy. So you fold a 2D, you get a 3D. You slice a 3D, you get a 2D. And if you rotate a 2D, you get a 3D. That's what we've learned in 2 days. Let me show you how it makes sense. Ready? Now. No, if you take a very thin slice, it's two-dimensional, right? Whatever. All right, check it out. By the way, I broke this, which is super cool. Not. All right, so that bums me out. No. You're gonna have to use your imagination because things break, unfortunately. 3D printers aren't the best. Okay, now check it out. By the way, check out the Lee Library social media. You'll see Mr. G. Yeah, you saw me. That's right. All right. I'm only viral. No big deal. Wake up. We're almost done. Wake up. Don't listen. Look. What? All right, now, check it out. This is supposed to be a flag, okay? And it's supposed to simulate what's going on here. So what's happening here is they took a two-dimensional shape, rotated it around an axis, and when you take a rectangle and you rotate it, you end up with a circle on the top and a circle on the bottom. What is that shape? Cylinder. So when you take a rectangle and rotate it, it becomes a cylinder. Okay? Now, as you'll see, if you go to the Lee Library social media, see cool stuff like Mr. G using 3D printed stuff like this. Here's my demonstration for today. What if you took a right triangle, wake up, and rotate it across the axis? What do you think it's going to do? Huh? Look! Everyone say, ooh, oh, wow. Wow, I wish I was looking at Mr. G. That's crazy. Can't believe you did that. What happens next, you'll never believe. All right, so watch this. Ready? Oh. All right. Thank you. Okay. It was like 80%. All right, I almost fell down too. All right. Now, what does this create when you rotate it? Pointing at the top, circle on the bottom. What's that called? A cone. I guess it's probably even faster if I just do it with my hands. Kind of looks like a cone with the circle on the bottom and it's pointing on the top, right? Okay, so that's another example. And here's your last example. What if I take a half circle, a semicircle, and I rotate it? What could it possibly make? A spear that you throw in the air? Oh, a spear. Yes. It'll be circular and it'll go like that. Okay, there you go. It makes like a ball shape. Okay, you get the idea. You know, pronunciation matters. We don't want to. No. I'm just saying we all need to articulate. All right. Now. No. I don't know what any of y'all mean. What do y'all mean? Maybe. Yeah, but if I'm holding this and you say spear, you know? Anyways. I kid. Now, number 10, 11, 12. We're going to do this real quick. If you find the cross section, what does it say? Parallel to the base. Does everyone remember? Parallel to the base is the same as the base. But I don't have a picture here, right? But if you just read it, it tells you right here. What is the base of a right triangular prism? A right triangle. Does everyone know that the first name is the base? Okay? Okay. Parallel to the base, matches the base, and it's right there. It tells you what it is. Put a box around right triangular. Okay? So if you take that right triangle and then do what with it? Rotate it. Very big, bold right here. Okay, so if you take the right triangle and rotate it, you'll remember Mr. G holding this right triangle and doing this thing, pointing at the top, circle on the bottom. What do you call that shape? A cone. Okay. So I'm gonna draw a little picture of it. You don't have to, but this is what we're kind of imagining. A right triangle. When it rotates, it kind of makes a circle on the bottom, and it's pointing at the top. That's a cone. Okay. Okay. What about the next one? Cross section parallel to the base of a square pyramid. What is the base of a square pyramid? A square. It's right there. That's the name of it. So you're going to take a square and rotate it. Now, again, this is broken, but when you rotate a square or any type of quadrilateral, circle on the top, circle on the bottom, what does it make? Cylinder. Because you're spinning it in a circle. Not a cube because you're circling it. You're spinning it around. Spin it around. Bring it around town. All right, last one. In the back, what do you call it when you take a semicircle, okay, and you rotate it? Put a phone away. Put a phone away. Rotate a semicircle. Well, we already. Careful what you say. A sphere, right? Okay. Half circle, spin it around, you get a sphere, okay? So, goodness gracious. Half circle. It's a sphere. Okay, now, you can either finish yesterday's, start today's, get home. Make sure you finish the stuff you need to do here because the nets are here. Is that an assignment? Yes, sir. Now, let me tell y'all, we are like the other classes started this before the break, so I'm trying to do a tad bit of catch up. So that's why we have a lively thing. All right, so finish yesterday's and then begin today's. Try to finish today's while you're at it.